Morning students. This chapter will study about the two processes of light, reflection and refraction. So now let us see what do you mean by the reflection of light. Now we see so many objects around us. However, when we are in dark room or during night time, we are not able to see the things around us, or the things are not visible to us. Now the question arises, what makes the things visible? Now during daytime, the sunlight helps us to see the object. So an object reflects light that falls on it, and this reflected light, when received by our eyes, enables us to see the things. We are able to see through a transparent medium as light is transmitted through it. Now transparent medium means here glass, pane, or the transparent glass if you take, or the water is also transparent. So through the window pane, which is transparent, we can see the things outside the window pane. And then also we are able to see through the water at the base of the river or the pool or the lake. Whatever things are lying, that can be seen through the water. Or you take a glass of water and put a coin in it. As water is transparent, we can see the things which are there at the bottom of the glass. Now there are also a number of wonderful phenomena associated with the light, such as the formation of images in a mirror. When you stand in front of the mirror, you can see your image. Then laughing mirrors are also there, so that they are also the different shapes or the funny images of you are found, and that makes you laugh. Then twinkling of the stars in the sky, then beautiful colors of the rainbow, then bending of light in the medium. All these things, or all these different phenomena, we have to study in this chapter. So the study of the properties of the light helps us to explore them. Now, observing the common optical phenomena around us, we may conclude that light seems to travel in a straight line. Now here, for example, now we know that how the light travels in a straight line. Like if you have a small hole on the roof of the house, then through that house, if the sunlight enters the house, you can see it travels in a straight line. Or you sit in a cinema hall. There the light from the projector, you observe carefully, even it is dark, you can see that the light, it travels in a straight line, it falls on the screen. So this shows you that the light travels in a straight line. So in this chapter we shall study the two phenomena of light. One is reflection and refraction using straight line propagation of light. Means you have to assume that the light travels in a straight line. Now these basic concepts will help us to study some of the optical phenomena in nature. We shall try to understand in this chapter the reflection of the light by the spherical mirrors, and also the refraction of the light and their application in the real life situation. So now let us first see about the reflection of light. Now reflection of the light, here we know what are the reflection. Here the surfaces which are reflecting light, the most common one is the plane mirror. Then any steel surface you take, such as utensils, or any steel utensil you take, so that also is the reflecting surface. Now we are familiar with the laws of reflection. Now let us first see, again recall the laws of reflection. That first law of reflection is the angle of incidence is equal to the angle of reflection. Now angle of incidence is the angle made by the incident ray with the normal, and angle of reflection is the angle made by the reflected ray with the normal is called as the angle of reflection. Now this all you have studied it in 9th standard. Now let us see this one. These two laws you let us recall. The angle of incidence is always equal to the angle of reflection. Then second law is the incident ray, the normal to the mirror at the point of incidence and the reflected ray all lie in the same plane. Now these laws of reflection are applicable to all types of reflecting surfaces including spherical surfaces. Now spherical surfaces means here see this one. Now first before that let us see the properties of the image formed in a plane mirror. Now when you stand in front of the mirror, then your image is formed inside the plane mirror. So what are the properties of that image formed in a plane mirror? The first property is that the size of the image or the image formed in a plane mirror is always virtual and erect. Now two types of images are formed. One is virtual and the second one is real. Now virtual means the image cannot be obtained on a screen, and real means the image formed can be obtained on a screen, that is called as the real image. Now when you are standing in front of the plane mirror, then the characteristics of the image are the image formed by the plane mirror is virtual and erect, means it is straight. Then second characteristics is size of the image is same as that of the object. Then third property is that the image formed is as far behind the mirror as the object in front of it. So if you are standing at a distance of 1 meter from the mirror, then your image will be formed inside the mirror at a distance of 1 meter. Then image is laterally inverted. It is the fourth characteristics. Laterally inverted means the left hand appears right and the right hand appears left. Now the question arises, what would be the images when the reflecting surfaces are curved? Now example of the curved reflecting surfaces, take the spoon. Now spoon, you can see it is curved from inside and the outer part is bulging. Now you can see your image inside the curved part as well as on the bulging part. So such reflecting surfaces, they are called as the spherical reflecting surfaces, means they are the curved reflecting surfaces. Now the question arises, what will be the nature of the images formed in a curved reflecting surfaces? Now for that, here you take a spoon and then inside the curved surface you try to see your image. So and you will see that this image is larger than your actual face, means the size of the image in this case is not same as that of the object. Then now you move the spoon slowly away from your face and observe the image. Now you will see that the size of the image, it becomes bigger and bigger and finally it disappears. Now you take the bulging side of the spoon, means the other side of the spoon, and again you see your image in that. So what we observe, that the size of the image, it is smaller than that of the object, and as you move away, the size of the face becomes smaller and smaller, and finally the object disappears. So now this curved surface of the shining spoon could be considered as a curved mirror. The most common type of curved mirror is the spherical mirror. Reflecting surfaces of such mirror can be considered to form the part of the surface of the sphere. So such spheres whose reflecting surfaces are spherical are called as the spherical mirror. Now let us study about the spherical mirror. Spherical mirrors means it is derived from the word sphere. Now if you take out the mirror, you can see that the front surface, it is shining and the back surface is painted. Now due to that, otherwise that mirror is nothing but the transparent glass sheet. Now that painted surface which is behind the which is there on one side, it makes the other surface of the glass shining or reflecting on, or it makes it into a mirror and you can see the image in it. Now if you imagine one sphere means just like a ball you imagine, which is painted from outside. Okay, so the inner surface will be what now? Shining. Now if you this one cut the surface of the sphere, of that sphere which is painted from outside and shining or the reflecting from inside, so that's mirror, it is called as the concave mirror. Means spherical mirrors, they are of two types, concave mirror and the convex mirror. In concave mirror, how it is obtained? It is obtained from the sphere which is painted from outside and which is reflecting from inside. Whereas the convex mirror, it is obtained from a sphere which is painted from inside and which is reflecting from outside. Okay, now here this one, here you can see this one. So in case of spoon, with the help of spoon, how you can understand the concave and the convex mirror? The inner part of the spoon, that gives an idea of the concave mirror, and the bulging part of the spoon or the outer part of the spoon, it gives you an idea of the convex mirror. Is it clear? Now the center, now this here, see, now these two mirrors are shown here in the figure. This is the concave mirror. So you can see the concave mirror, it is curved from inside, and the convex mirror, it is curved from outside. It is curved from outside. So this are the two concave and the convex mirrors, or the spherical mirrors, which are shown here in the figure. Now this mirror, they are circular in shape. Like if you how you can understand here, they are circular in shape because they are the part of the sphere. So when you take an apple or the orange, and if you cut on one side, then how you get the surface? That surface is circular. So same way, the sphere or the ball gives an idea of the sphere. So that ball also, if you cut down, then you will get one circular piece, like a dish, you will get it. Okay, so that dish is such that this inner curved part, if it is reflecting, then it is a concave mirror. If the outer part is reflecting, then it is a convex mirror. Now the center, now we have to learn some terms related to the spherical mirrors. First is the pole of the mirror. Now center of the reflecting surface of the spherical mirror is a point called the pole. It lies on the surface of the mirror. Now the pole is usually represented by the letter P, capital P. Then reflecting surface of the spherical mirror forms a part of the sphere. Now this sphere has a center. This point is called as the center of the curvature of the spherical mirror. So that sphere which is there, it has got the center. So that center is called as the center of curvature. Now center of curvature of the concave mirror, it will lie in front of the mirror. And the center of curvature, now see here, this is the concave mirror, this one. So this center of curvature of this mirror, it will lie in front of the mirror. Now for this convex mirror, this is the convex mirror. The center of curvature, where it will lie, this dark part, it shows you the reflecting part. So center of curvature of the convex mirror, it will lie behind the mirror. Clear? So now next we will see here radius of curvature. Now radius of the sphere of which this mirror is the part is called as the radius of curvature. Now radius, and it is represented by capital R. Now this here in the figure, this one, see now, like this here the sphere will be. So this sphere, it is cut into this part. So this cut, when it is cut here, then the center of the sphere, this is called as the center of curvature. Now for the convex mirror, concave mirror, for the concave mirror, the radius of curvature will lie, center of curvature will lie in front of the mirror. And for the convex mirror, the center of curvature will lie behind the mirror. Then next we will see What do you mean by the principal axis? Now imagine a straight line passing through the pole and center of curvature of the spherical mirror. Now this line is called as the principal axis. Now the principal axis, it is normal to the mirror at its pole. Means here, see this line here from the center of curvature to the pole of the mirror P. So this line, it is called as the principal axis. So it is perpendicular to the mirror, or it is normal to the mirror. Now next we will see what do you mean by the principal focus. Now principal focus means, here see, this is a concave mirror. Now for this concave mirror, here the rays of light, here they are incident, a beam of light which consists of the rays parallel to each other, they are incident on a concave mirror. Now this P, it indicates the pole of the mirror. C indicates the center of curvature. Now this ray of the light, this one which is incident on the mirror at point D, it gets reflected and then it passes through the point F. The second ray again, which is parallel to the principal axis, after reflection again it passes through the principal focus. So you can see for the remaining rays of light also, the incident rays, they are parallel to the principal axis. After reflection they pass through the principal focus. So what we observe, this one, that all the rays of light, when they are incident on the mirror, after reflection they pass through the principal, passes through this point F. So this point F, this is called as the principal focus. So how you will define the principal focus of a concave mirror? The rays of light after this one falling parallel to the principal axis, after reflection passes through a point on a principal axis. So that point is called as the principal focus. Now let us define the principal focus of the convex mirror. Now this is the convex mirror. Now in convex mirror, you can see this is how the convex mirror looks. Again here we will have the principal focus, we will have the pole of the mirror P. Now here the center of curvature, it lies behind the mirror. So C is shown here. Now this ray of light here, you can see when it is parallel to the principal axis here like this, then it gets reflected here. The outer portion here, this one, the arrow pointing outward shows the reflected ray. Now again the ray of light which is parallel to the incident, parallel to the principal axis at incident on the mirror at E, it gets reflected from E. So these reflected rays here, when you extend, they appear to come at a point which lies behind the mirror. So that becomes the principal focus of the convex mirror. So what we observe in these two cases here, that the principle here for the concave mirror, the rays of light converge at the principal focus, and for the convex mirror, the rays of light appear to diverge away from the principal focus. It moves away from the it appears to come from the principal focus on the center of on the principal axis. Then this one, now the distance between the pole of the mirror and the principal focus is called as the focal length. So here also PF is the focal length, and here in this case also PF is the focal length. Now it is observed that this focal length, it is denoted by small f, and it is observed that this principal focus, it lies at the midpoint of the center of curvature and pole of the mirror. Now distance PC in this figure here, this is called as the radius of curvature, it is denoted by R, and then this is called as the and here this principal focal length, it is half of the center of the radius of curvature. So here also F lies between P and C. So focal length is also here in this case also have the radius of curvature. Then next is here image formation by the spherical mirrors. Now we will learn. Now for image formation here, now for the different positions of the object where the image is formed, that you have to learn for the concave mirror as well as for the convex mirror. Now we know for, now it is in order in here. Now you will see innumerable or the infinite rays, they are incident on the mirrors. Now out of those infinite rays, you have to consider only the direction of any two rays, and those rays after reflection, wherever they meet, there the image will be formed. Now first is here this one, the first ray, you will see the ray parallel to the principal axis after reflection passes through the principal focus. Now for both the mirrors, concave as well as convex, we will see this. Now see here this one, P is the pole of the mirror, F is the principal focus, C is the center of curvature. Now this ray of light, it is incident on the concave mirror. After reflection, it passes through the principal focus. So this is one direction of the ray of light. Now for the convex mirror, how it will be here? Again, P is the pole of the mirror, F is the principal focus, and C is the center of curvature. Now the ray of light is parallel to the principal axis. Now after reflection here, it will appear to come from the principal focus. So this dotted line indicates what? That the ray of light, it lies behind the mirror. Now next we will see this one, next direction of the ray of light we will see. Now second case is here, this one. If the ray of light, second, the ray passing through the principal focus of the concave mirror, or the ray which is directed towards the principal focus of the concave mirror, convex mirror, after reflection will emerge parallel to the principal axis. Now here you can see this, the arrow moving towards the concave mirror, it shows you the direction of the incident ray. So the ray of light which is passing through the principal focus, after reflection, it is parallel to the principal axis. So it is just the vice versa of the first direction of ray of light. Now here also you can see this ray of light which is moving towards the principal focus. Then it, after reflection, it becomes parallel to the principal axis. Now third direction of ray of light we will see, the ray passing through the center of curvature of the concave mirror, or directed in the direction of the center of curvature of the convex mirror, after reflection is reflected back along the same path. So here you can see, if the ray of light is passing through the center of curvature, it will also be reflected back to the center of curvature. Then here also same way, this is for the convex mirror, that the ray of light, when it is passing through the center of curvature, it will also reflect through the center of curvature. Then next, fourth direction of the ray of light is here, the incident ray obliquely to the principal axis towards the point of on the concave mirror or the convex mirror is reflected obliquely. The incident and the reflected rays follow the laws of reflection at the point of incidence P, making equal angles with the principal axis. Remember that in all the above cases, the laws of reflection are followed. Now next we will see here the image formation of in a concave mirror. Now let us consider this example here. Now first, when you are drawing this, draw the curve for the mirror. Mn is the mirror. Then at a distance of 1 centimeter or at the distance of 2 centimeter, take the principal focus, and at a distance of 4 centimeter, take the center of curvature. Now the ray of light, when it is so the first ray of light is parallel to the principal axis. After reflection, it passes through the principal focus. Now the second ray of light is passing through the center of curvature. It also passes through the center of curvature, and this third ray, you can see, it is parallel to the incident principal axis. After reflection, passes through the principal focus. So what we see, when the object is at infinity, the image is formed at the principal focus. So this, when you can observe this one, sun, you can take the sun as the object. So sun is at infinity, so the image is formed at the principal focus. So this can be used approximately to find out the focal length of the mirror. Now second we will see when the object is beyond the center of curvature. So you can see AB is the position of the object. Now one ray passing through point A, it is parallel to the principal axis. Reflected ray passes through the principal focus. Then second ray is passing through the center of curvature. The reflected ray also passes through the center of curvature. Now these two reflected rays, they meet at a point between C and F. So here you can see this image, which is A dash B dash, which is formed of AB. This is the inverted image. So what we conclude from this here, if the object is beyond the center of curvature, the image is formed between the center of curvature and the principal focus. Now nature of the image here, this image AB, it can be obtained on a screen. So this is a real image. An image, it is how it is real and inverted. So when you're defining the object, when you're defining the image, how it is formed, you have to decide, write down what is the position of the object, and corresponding to that, what is the position of the image. And after that, you will write down whether it is real or virtual. And third thing, you will write down whether it is inverted or erect. Inverted means upside down and erect means straight. Then third thing, we will see if the object is at the principal focus. Sorry, object is at the center of curvature. Now see, AB is the position of the object. Now AD is the ray of light which is parallel to the principal focus. After reflection, it passes through the point F. Then the second ray of light, it is passing through A, and then it also passes through F. So we can see that after reflection, the reflected rays, they meet again at this point. So if AB is the object, then A dash B dash, it is the image. So what we see, that the image, it is inverted. It will be a real image, and size will be what? Size will be the same as that of the object. So when the object is at the center of curvature, image is also formed at the center of curvature. Size of the image will be same as that of the object, and the image obtained, it is a real image. Then fourth one, we will see if the object is between the center of curvature and the principal focus. Now what we see here, this one, the ray of light, it is parallel to the principal axis. After reflection, it passes through the focus and come at this point. Then second ray of light, we will see passing through the center of curvature. So the reflected ray also passes through the center of curvature, and it meets at point beyond the center of curvature. So what we observe, that when the object is between the center of curvature and the principal focus, image is formed beyond the center of curvature. Nature of the image is again real. How it is image, inverted or erect? It is inverted. Size of the image bigger than that of the object. Now let us consider this position now. If the object is at principal focus, then the image is formed at infinity. So what we see here, that again see here, the rays of light here, like this reflected rays, they do not meet. So the image is formed at the infinity. Then if the object is within the focal length here, this phase here, between the pole and the principal focus, then the image is formed behind the mirror. Now this image, it cannot be obtained on a screen. So this image is now virtual. And since it is a virtual image, you cannot write down the nature of the image. So all these image formations which you have learned, they are there in this table. So what we see here, observe the table carefully. The first table, this first column, it gives you the position of the object. Second column gives you the position of the image. Third column gives you the size of the image, and fourth column gives you the nature of the image. So when the object is at infinity, image is formed at the focus. Size of the image is what? Highly diminished, and point size. Highly diminished means small it is. So this you can understand, when the sun is at infinity, the image is formed at the focus. It is small. Image is how real and inverted. You can obtain the sun's image on a paper. Then second one is when the object is beyond center of curvature, beyond C, the image is found between F and C. Image is again diminished, means it is small, and nature of the image is real and inverted. Now corresponding to this second one, now you take this which one, this fourth type of image. So these two are the vice versa of each other. So here now, if the object is between C and F, then image is formed beyond C. Now beyond C, and how is the nature of the image? It is enlarged. And how is the nature of the image? It is real and inverted. Then if the object is at C, the image is also at C. Nature of the image is same size. Again, nature of size of the image is same, and nature of the image is real and inverted. If the position of the object is at F, then the image is formed at infinity. It is highly enlarged. So this first and the fifth one, they are vice versa of each other. And then this one, second and the sixth one, they are vice versa. If the object is between P and F, image is found behind the mirror. How is the image? It is enlarged. Now here this is virtual and erect. Virtual means it cannot be obtained on the screen, and it is erect. For rest all, the nature of the image is virtual and erect. I hope it's clear to both of you. Now, what are the uses of these concave mirrors? Now, these concave mirrors, they are used in torches, searchlights, and vehicles' headlights to get powerful parallel beam of light. They are also used in shaving mirrors. Then they are used by the dentist to get the large image of the teeth of the patients. The large concave mirrors, they are also used to concentrate sunlight to produce heat in the solar furnaces. Now next we will see the image formation in convex mirror. Now image formation in convex mirror, only two positions of the objects we have to consider: when the object is at infinity and when the object is between the infinity and pole of the mirror. Now when the object is at infinity, the image is formed at the principal focus. So very simple diagram here. Just keep the object at a very large distance. Now see here, this dotted line shows that the object is at infinity, and then all the reflected rays, they appear to come from the principal focus, which is behind the mirror. So image is formed at the principal focus. And when the object is at the is between infinity and pole of the mirror, between infinity and pole means at any position in front of the mirror, when the object is there, that time the image is formed behind the mirror, and the nature of the image is what? Virtual and erect. So only virtual and erect images, they can be formed in case of a concave mirror. Now clear. So what are the uses of the convex mirror? Convex mirrors, they are used as a rear view mirror in the vehicles. The driver or the rider of the two-wheeler, he can get the overall view of the traffic coming from behind him. So in order to facilitate safe driving. Now convex mirror, they are preferred because they always gives an erect though diminished image. Also they have a wider field of view as they are curved outwards. Thus convex mirror enable the driver to view much larger area than it would be possible with the plane mirror. Now this sign convention of the spherical mirrors we will see later on.